Okay, now we'll solve one more problem based on page tables. Here they have asked to find the total size of page table and what are the things given. Main memory size is given to 56 MB, page size is 4 KB, then logical address is 40 MB, and process size is 4 MB. Okay, what we have to calculate is total size of page table. Okay, so first we'll draw the diagram. Uh, this is his logical address having page and the instruction offset. Okay, so this is your page table. Yes, this is the size of page table which we have to calculate, and this is your physical address with frame and the instruction offset. Okay, so this frame will go here from page table, and this is your physical address of main memory. Okay, so what is given to us? We know the size of main memory, we know the page size, we know logical address, and we know process size. Okay, so first thing what we have to do is first thing we will find out D. Okay, D is what? Instruction offset. Right, so we'll find out offset. Okay, how to find out that? Page size upon, it's a byte addressable, right? So 1B. So what is the page size given? 4 KB is the page size given, byte addressable. So we'll get 4K, that can be written as 2 raised to 2 into 2 raised to 10. Okay, so that will be equal to 2 raised to 12. Okay, so this is your D. So you can write here D. D will be for how much? 12. Right, 12 bits. So this will be also 12 bits. Okay, now what is given? Memory size is given. Main memory size is given as 256 MB. Okay, and what is how to calculate physical address? Physical address is equal to main memory size upon byte. Okay, so main memory size is 256 MB upon 1 byte addressable. So we'll get 256 million entries here. So this will be 2 raised to 8 dot 2 raised to 20. So we will get 2 raised to 28. So this is your physical address, right? This is your physical address. So we can write here physical address as 28. So can you find out the frames? 28 minus 12 will be 16. So that is a frame set. Okay. So the third step the third step will be we want to calculate the number of pages. Okay, so logical address is given, that is 40 bits is given. Okay, so now you know D. Okay, you know D and you know the logical address is 40. Okay, so 40 minus 12 is how much? 28. So this will be 28, right? So what about number of pages? Number of pages will be equal to process size upon page size. Okay, so process size is 4 MB which is given, and page size is also given 4 KB. So this will get cancelled and you will get 1K. Okay, so total number of entries in page table, total number of entries in page table is equal to 1K. Okay, now the last part is what? We want to calculate the total size of page table. So total size of page table is equal to how much? What is the formula which we have seen in the last lecture? Total entries in page table into size of each entry. Now total entries will get from here, right? 1K. And from where we'll get size of each entry? So size of each entry will get it from here. Okay. This is size of each entry. So 16. Well, what is 16? 16 is, what is 16? I can write it as a 2. Okay. So, okay, sorry. So, here you can write 1K into 2 bytes is equal to 2 KB. Okay. So, what is the size here? Here you can write this 2B. 2B. The size of the page table is how much? 2 KB. Okay, this is how you can solve the problem.